So I'll use that same slide so that it will be better. So let me rename it. Project number 3. Random process. This is part 4. I've already uploaded part 5 and 6. So this was part 5 that I discussed, and we'll start with the part 6 now, right? So the date is 17/10/20 M7. So this will be just part 6 of the video, right? So classification, we saw two things. Classification of random process. We saw strict sense stationarity process, WSS process, and in this video we will see what is ergodic random processes, and we will solve some numerical. So these are the three things that we are going to we have as a classification of random process. So if you see what is ergodic process is, right? So this is ergodic process, and before that, let me talk something about time averages, so this will be clear, more clear. So let me write here only. What we saw, statistical averages, right? Till now we have done this a lot. So this is statistical averages. So we saw there xt that you call DC value. So you denote it by mu x. It should be a function of time. So this is minus infinity to plus infinity, x fx x t dx. This is x squared t. So this is defined by minus infinity to infinity, x square fx t dx, and then the variance, which is xt, subtract the DC value of this xt, and then find the power, that is AC power or variance. So we denote it by sigma x square t. This is minus infinity to plus infinity, x minus mu x t square, and this will be fx x comma t dx. So I can go on define expectation as a function of expectation of any function of xt. So in general we have expectation of any function of xt, and we can write it as minus infinity to infinity, and this will be g small x fx dx. And what the you find here when you fix time, so inside the expectation whatever goes expectation of, it should be always a random variable, right? It should be random variable. So whenever I write expectation of something, then it means that we don't want to see this average with respect to time, but we calculate the average with respect to the voltages or currents, or it can be anything. But this integration are with respect to x, the values, right? So these are called as statistical average, or you may call it data average, right? For one random variable, you can define any average by using this formula. This is so important, and for our, as a communication engineer, we mostly work with this three averages. One is the DC value, one is the mean square value, and one is the variance, or you can say it's a total power. When you square it, you will get total DC power, and this is the AC power. And other than this, if you take any function of xt, not these functions, so you may generalize this, you may find that what should I say, the formula for that by using this thing. But whatever you see, if you have one random variable, square it, one random variable, you made some function of it, but only one random variable. So you need to use first order PDF. So this is for one random variable. So if I have one random variable, and one random variable, in case of random process, when you fix time, you get one random variable. When you fix time at one time, you will get one random variable, right? So these are some example of first order statistical averages, because they use first order PDF. If you see the second order statistical averages, then again I will have some set of I will have the formulas, and in that, if I have two random variable, so I have to sample the random process at two times. Like at t equal to t1, I get one random variable. At t equal to t2, I get another random variable. So this g is any function of this two random variable. Now I have function of two random variable. They are something function of one random variable only, xt only, right? So this formula, this is what two random variables. So I need to talk about joint PDF of two random variable. So in this expression, I will have two integration, because this is two random, these are two random variables. So this will be x1, let me write in the blue pen only. So this will be x1 minus infinity to infinity, then x2 minus infinity to infinity, and this will be simply like that, like here what we did, capital X is removed by small x. So I have two capital X's of t1 and t2. So this will be x1. So this is a random variable xt1 when it takes the value of small x1. This is a random variable xt2 which takes the value of small x2. So this is gx1 x2. Now I have to use joint PDF. So that will be x. It will be, this random process will be sampled at two different time, at t1 and t2. So when t1, the random process becomes random variable, that is xt1, and it takes the value of x1. When random process is sampled at t2, it becomes a random variable xt2. So this is my xt1, which takes the numerical value of x1. This becomes xt2, again a random variable, because whenever I sample the process, I get a random variable. So xt2 takes the value of x2. So this is called joint PDF. And I have to integrate with respect to x1 as well as x2. This is fairly simple. So For our concern, again, I can have infinite number of functions defined using xt1 and xt2. These are the two random variables. This is one random variable and this is another random variable. It's another random variable. So two random variable. I can define any function of xt1 and xt2. So let me define two most widely used functions in our case as a communication engineer. So that is when you have xt1 and xt2, multiply them. It's just a multiplication of these two random variable. So xt1, xt2. So this is what the multiplication of these two random variable, and you get one function, that is gxt1 xt2. And when you find the average, that is expectation. So this is denoted by rx t1 comma t2. This is so important that we give it a name that is called as auto correlation function. Again, I am repeating everything so that you will understand this point easily. So this is auto correlation rx t1 t2, and this will be double integration. So again, x1 to minus infinity to plus infinity, x2 will be from minus infinity to plus infinity, and this is my gx t1 t2. So what it says, you just replace xt1 with x1 and xt2 with x2. So replace xt1 with x1 and xt2 with x2 and multiply them. So xt1 multiply with xt2 will be a small x1 multiply with x2. This is just a point in the random process when you fix time as well as omega. Now you need to use double-sided second order PDF. So that will be the same thing. So this will be x1 comma x2 and then t1 comma t2, and this will be dx1 and dx2. This is called autocorrelation function in a statistical sense. Now we have one more, that is xt1, and subtract the DC value of xt1. So DC value is nothing but mu x at t1, evaluated at t1, and xt2 subtract the DC value of this random variable. So this is a mu x, mean of the random process at t equal to t2, and this is called as cx t1 comma t2. This is called covariance. So this is called auto covariance. Auto is simply when you have the random variables from the same random process. So these two random variables are from the same random process. That's why the name is auto. Co means it involves two random variable, xt1 and xt2. So the meaning is co is what? Two random variable, and auto means what? Random variables from same random process. You might have two random process, xt and y of t. So you sample xt at t1 and yt at t equal to t2, then that is called as cross covariance or cross correlation. These two are only important. So we studied this one also. In fact, how many statistical averages I can define using this xt1 and xt2? Again, it is xt1 into xt2. I can write xt1 divided by xt2, or I can write xt1 square into sine of xt2. That is also a function of xt1 and xt2. So there are infinite such functions I can define on this xt1 and xt2. So this is called two random variables. So you need to observe the random process at two time, t1 and t2. It is one random variable, means to get one random variable from random process, you have to observe the random process or sample the random process at only one specific time, and that is t over here that I have written. But these are called as statistical averages. Can I have three random variables? The answer is yes. When you have three random variables, so I will have function of three random variables. xt1, let me write here, that is xt1, xt2 and xt3. Now I know that one, how to get one random variable from the random process. You fix the time, you get random variable. You fix the time, you get random variable. You fix the time, you get a random variable. So 3 random variables from the same random process, and then you can also you can find the expectation of this function of 3 random variables. So I'm saying it again, expectation always take input argument as random variable or function of random variable. So all things inside this expectation operator, they are the random variables. Again, I can write the definition of this. I need 3 integration: x1 minus infinity to plus infinity, x2 minus infinity to plus infinity, x3 minus infinity to plus infinity. I have not written the definition of this cxt1 t2. You can write that one, or you can check the previous slides, because I've written that there, right? Now I can write this one as gx1, x2, x3. These are just sample points. 1 point. When you fix the time as well as omega, you get one value, that is x1, x2 and x3. And now you have to use third order PDF, that is function of 3 random variable, or joint occurrence of 3 random variable at time t1, t2 and t3. And this will be dx1, dx2 and dx3. And you can define infinite number of such such function, which is a function of 3 random variables. You can choose any function. Let's choose xt1, xt2, xt3 as, let's say, I don't know, let's say xt1 times cos xt2 plus xt3. This is one function that I can define. I can write the formula for this. It's fairly simple. So if you write the expectation of this thing, it's a function of 3 random variables. So this will be cos xt2 plus xt3, and this will be simply 3 integration. I need to write minus infinity, minus infinity, minus infinity to plus infinity, and then I can write, instead of xt1 I will write x1, then it is multiplication, so I will write multiplication, then I write cos, then instead of xt2 I will write x2, instead of xt3 I will write x3, and then I need to use joint PDF of 3 random variable. When xt1 takes x1, x2t takes x2, and x3t random variable takes the value of x3, and this will be t1, t2, t3, and this will be dx1, dx2, dx3. So this is what the averages are. You can define any function. You can just use this. The point is what? The point at which you know this formula, you can write any average which is dependent on first order PDF. If you know this formula, which is expectation of 2 random variable, you can write expectation of any function of 2 random variable. So, and when you know this formula, then you can write any function of expectation of any function of this 3 random variable, like this. This is an example, but we don't use this, we don't have this, and they are not required for our analysis. I hope this makes sense. Anybody is having any doubt in this? किसी को doubt है इस पे? Yes. Say something. No? No doubt? Yes or no? Any doubt in these formulas?
No, sir.
Be careful when you are remembering them. When you remember them, you will forget that. So this formula, 3 parameters we require, and this two we require. It's very simple, no? इसमें फॉर्मूले में है ही नहीं, एक ही फॉर्मूला रटना है आपको, बाकी फॉर्मूले आपको जस्ट जनरलाइज करते जाना है, इतना ही करना है, nothing else. So I am not teaching you the formulas, but I am teaching you how to remember these formulas, because they are very simple. So if you watch these videos properly, you will get everything there. Now these are the statistical averages. Now what about time averages? We have seen averages, time averages. Time averages, it's fairly simple to understand that if I have random process, so it will be collection of all sample functions. They are just the waveforms. So let me choose 3 sample functions. Now these are the function of time, so they are function of time. I have chosen only these 3. It may be any number of there. In fact, it is infinite sample functions. In general, noise is something which has infinite possible waveforms. Till now we were talking only what, when you fix the time, when you fix the time. So when you fix the time, you get random variable. This is like 3 values in that random variable when you fix at t1, t2, t3. Whenever you have to define random variable, you fix the time. That's it. But what we are doing that there was, we are averaging vertically. Expectation is working vertically. So when you write expectation of xt1, you don't care about other time. You just care about this t1 time. So when you write expectation of xt1, just take this data and the PDF of this data and you do averaging. These are called statistical averages. I hope this is clear. So whenever we say statistical averages, means we are working vertically. When we say time average, we work in horizontal direction. So because when I say time average, this is a waveform. Just look at this waveform. Just look at the first waveform. If I ask the question, this is a signal which is a function of time t. So can you tell me what is the DC value of this xt? So let me write this as a, any one of this is just a x1t, x2t, x3t, like this. So when you average this, you are working horizontally with respect to time. When you say time average, right? I may ask the same question, what is the DC value of x1t? Or let's say any xt. Okay, let's say the DC value of x1t. So what you will do? How to find that? We know this. How to define xt? So again, I can have any function of xt. So let me write the first, what is the DC value? Let me write time average, time DC value. Again, we will say this average. Again, I can say this is time mean. But now the word is time here, because now we are averaging with respect to time. So this is denoted by this triangle, and you write simply xt. The notation should be understood by each one of you. I'm not writing here expectation of something. Now here it is talking about waveform or function of time. But when you write expectation, inside the expectation there should be only random variable or function of random variable, right? That was statistical average. Now see this point. This is the notation that we use. We don't write e because it will get confused. We will get confused. So we write this kind of thing, triangle, and we write xt. We call it average of xt, DC value. Sometimes people write xt and wavy bar like this, xt and this one. Small, whatever I am writing is small, because now we are talking one sample function at a time. All this collection is capital XT. All this collection is capital XT, which is random process. And random process output can be x1t, it can be x2t, it can be x3t. These are the sample function. And when you say averaging over time, so you have to first find out that at what time which sample function you are working on, either this or this, because capital XT is all these waveforms. I hope this is clear. So I can take x1t and find the average. I can take x2t, I can find the average. I can take x3t, I can find the average. So you will find DC value of x2t. Here you will find DC value of x3t, whatever it is, whatever it is. But the point is what you are finding horizontally. You are talking about horizontal direction. So before it was vertically. So that was with respect to x, the averages are, but now the averages are with respect to t. So the integration has to be with respect to t. How to find average of any sample function? This is very simple. We know that definition. We write as limit t tends to infinity 1 over t. It will be minus t half to t half, or you can write 2t and then minus t to capital T. That is also possible. And then you write xt dt. This is called area. And when you divide by t, you call it time average, time mean, time DC value. Now you can see this is with respect to time. This is capital T. You have seen this formula before in signals and system, and you have used it a lot. For periodic signal, you find A naught. That is nothing but this formula, right? So this is for a periodic signal. For periodic signal, this if xt is periodic, then this formula becomes 1 over t, or you write t naught, then it becomes minus t naught half to t naught half, and then you write xt dt. If xt is periodic, then you work on the time period. So t naught is time period. This formula says it can be also any integer multiple of t naught, like 2t naught. You can write minus t naught to plus t naught. See this point, the integration range is for one time period, so you divide it by one time period, but the integration range is two time period, then it has to be divided by 2t naught. Why not here? This will be limit t tends to infinity. It may be like 1 over 2t, and this will be minus t to capital T xt dt. It can be 3t also, but it should be integer multiple of t, and these are always going to give you same answer. So this implies this also true. This is same. Nothing wrong with that, but working with one time period is better than working with two time period. If you want to go with this formula, you can go with this formula. If you want to use this formula, you go with this formula. Both will give the same answer. Why this is like this only? I can write like this, t naught. I can start from t naught and I can go to 3t naught. Again, the range is 2t naught. Here the range is 2t naught. Here the range is t naught. So that's why divided by t naught. Here the range is 2t naught divided by 2t naught. Here the range is 2t naught divided by 2t naught. And this will be xt. Everything is same. Everything is fairly same. But it cannot be non-integer multiple of t naught. It has to be integer multiple of t naught. This is the meaning of DC value. How you calculate power? So this is DC value. So how to get DC power? What is the DC power? DC power has to be DC square. So it has to be DC square. Like here, this is a time DC power, right? So it has to be xt square. Okay. Now let's come to the total power. Total time average power. Not it's a expectation of xt square, but it's a time average. So total power, you can call it mean square value. I should write the representation will be, instead of xt I will write x square t, and I can write the definition. Limit t tends to infinity minus t by 2 to t by 2, or you can write t to infinity minus t2 plus t. Oh, sorry, I forget that averaging. It's not area, it's average. So it has to be divided by, let's use 2t or t, whatever it is. And let's go from minus t half to plus t half, and you just square it and you do dt. So you take xt, square it, find the area. So this is area of x square t, and when you divide by time, this whole thing is called average of x square t. Here you go and check this formula. This is area of xt, and it's the average of xt. It's the area of xt, and divided by time will give you average of xt. It's the area of x square t, and it will give you average of x square t. People call it mean square value. People call it mean square value of xt. You may call it mean value of x square t, right? This is what the meaning is. This is how you find total power. But if again xt is periodic, same goes here also. It will be for one time period. So t naught minus t naught half to t naught half, and this will be x square t dt. You want to have 2t naught, you can take 2t naught. It will be from minus t naught to t naught x square t dt. Here t naught is time period. This formula is valid for both periodic as well as aperiodic. Periodic as well as aperiodic. Here capital T is not a time period. It's not a time period. It can be any time. It should be large time, so that you make sense that t tends to infinity, because the limit is saying that when you increase t as much as you can, and when this limit exists, you will stop and you say the power exists and the power is this much. But when you have xt is periodic, then this formula becomes this formula. This is the meaning of total power. Okay, t naught is a time period. So t naught is time period. Okay, what I did, just see here. If you get any function of xt, or let me write first AC power. How to find AC power? Can anybody tell me how to find AC power? How to find AC power? This is DC value. This is total power निकालने के लिए. How to write AC power? Yes, उसका नोटेशन क्या होगा? xt में से क्या माइनस करना पड़ेगा टू गेट AC कंपोनेंट? x of t में से what I need to subtract to get AC component? From xt, what you need to subtract to get AC component? बोलिए भाई. I'm just tired now. Tell me how to find AC component. वेरिएंस निकाला ना आपने? यस आकांक्षा, आकांक्षा
Yes, sir.
what is AC component? What do you need to subtract from x of t? कोई सिग्नल दिया है, उसमें से सिर्फ और सिर्फ AC कंपोनेंट चाहिए, तो उस सिग्नल में क्या माइनस करना पड़ेगा टू गेट ओनली AC कंपोनेंट? हाँ, यस, इतना क्या डिफिकल्टीज है इसमें, वो समझ में ही नहीं आता। सपोज दिस इज अ साइन वेव, इसमें डीसी है या नहीं है साइन वेव में? सपोज दिस इज 3 वोल्ट, दिस वैल्यू इज 3 वोल्ट। यस आकांक्षा,
Yes, sir. DC उसमें
कितना वैल्यू है डीसी इसमें?
3 volt.
sir it can be 0.5 or 1.
3.5 और 1? क्या बात कर रहे हो यार, डीसी वैल्यू मतलब एवरेज वैल्यू होता है।
Sir 1.
हाँ, ओ माय गॉड, यहाँ पे डीसी वैल्यू कितना है? अगर ये साइन वेव है तो कितना डीसी वैल्यू होगा?
0 volt.
0। यहाँ पे कितना वोल्ट है डीसी आपका?
3 volt DC वैल्यू होगा।
गुड। सो अगर इस 3 वोल्ट को माइनस कर दूंगा तो क्या बचेगा सिर्फ और सिर्फ मेरे पास? बिकॉज डीसी कंपोनेंट माइनस कर दोगे तो क्या बचेगा सिर्फ और सिर्फ आपके पास? इफ यू दिस साइन वेव में से 3 वोल्ट को माइनस कर दोगे, डीसी वैल्यू हटा दिया, डीसी हटा दिया, तो क्या बचेगा उसमें? किसी भी सिग्नल में दो ही कंपोनेंट होता है, एक डीसी होता है और दूसरा क्या होता है?
Yes.
AC।
तो इस सिग्नल में से अगर 3 वोल्ट हटा दिया तो क्या बचेगा आपके पास? थ्री वोल्ट हटा दिया तो कहाँ पे एसी बचेगा ना उसमें? सो दिस विल बी एसी, यस और नो? इसमें डीसी है क्या? हाउ यू गेट दिस वन? लेट्स से दिस इज एक्सटी, और इस एक्सटी में से क्या माइनस कर दिया आपने? 3 माइनस कर दिया, तो क्या बचा? ये यही बचा, राइट? व्हाट्स द डीसी वैल्यू ऑफ दिस? 0 वोल्ट। यहाँ पे डीसी वैल्यू कितना था? 3 वोल्ट था। अभी 3 वोल्ट माइनस कर दिया तो डीसी बचा ही नहीं, जो भी बचा है सिर्फ और सिर्फ एसी बचा है। यस और नो? से यस और नो?
Yes, sir.
तो अगर आपको एसी पावर चाहिए तो आपको क्या माइनस करना पड़ेगा एक्सटी से? सिर्फ एसी चाहिए ना, एसी का पावर चाहिए, तो इसमें क्या माइनस करना?
वैल्यू माइनस
डीसी वैल्यू किसका? एक्सटी का? यस और नो? यस और नो?
यस सर।
तो वही तो कर रहे हैं यार हम लोग इतनी देर से। एक्सटी में से क्या माइनस करना पड़ेगा आपको? डीसी वैल्यू। और डीसी वैल्यू ऑफ एक्सटी क्या होगा?
वैल्यू
डीसी वैल्यू ऑफ एक्सटी क्या होगा? ये होगा, यस और नो?
यस सर।
इसका पावर निकालना है तो क्या करना पड़ेगा आपको?
इंटीग्रेट
मतलब स्क्वायर करना पड़ेगा। नोटेशन पहले बात कर रहे हैं हम लोग अभी। यस और नो? इज दिस पॉइंट क्लियर?
यस
सो अभी
सर।
इसको क्या करना पड़ेगा? एक्सटी में से पहले आप डीसी वैल्यू हटाइए वहां से। सो डीसी वैल्यू का नोटेशन ये होता है, और इसका फिर पावर निकालिए। पावर निकालने के लिए आपको स्क्वायर करना पड़ता है। सो ये जो ट्रायंगल दिख रहा है इसको बोलते हैं अपन एवरेज, और इसके अंदर जो भी है वो इंटीग्रेटर के अंदर जाता है। सी दिस पॉइंट, व्हाट यू डिड हियर? डीसी वैल्यू निकालना था, यहाँ पे पावर नहीं निकालना था। डीसी वैल्यू निकाला आपने इस तरीके से। डीसी का पावर निकालना है तो डीसी वैल्यू को स्क्वायर कर दीजिए, यू विल गेट डीसी पावर। सो कोई बोलता है 3 वोल्ट डीसी है, इसका पावर कितना होगा? 3 3 9 वाट, राइट? सो When you square it, you get total power. Xt, you square it, you get total power, because this xt is AC component plus DC component. Yes or no? Yes or no? This
Yes, sir.
xt is AC component plus DC component. So DC component निकालना है आपको, तो आपको क्या निकालना पड़ेगा? उसका एरिया xt dt डिवाइड बाई टाइम करना पड़ेगा. टोटल पावर निकालना है तो क्या होगा? आपको डायरेक्टली स्क्वायर कर देना है, क्योंकि इसमें AC भी है DC भी है. यस और नो?
Yes.
नाउ अभी सिर्फ आपको AC कंपोनेंट चाहिए, तो क्या करना पड़ेगा? पहले उसमें से xt में से, जिसमें AC और DC दोनों है, उसमें से पहले आपको DC हटाना पड़ेगा. और जब जैसे ही DC हटाए तो फिर उसका पावर निकालना है. तो उसका फॉर्मूला क्या बनेगा? अगेन लिमिट t टेंड्स टू इंफिनिटी 1/t minus infinity to plus infinity, and whatever is there inside this triangle, it goes directly there. So this will be what? xt minus dc of xt square dt. कोई दिक्कत है इसमें? कोई प्रॉब्लम है इस फॉर्मूले में?
No, sir.
This is called AC power. This is how you find AC power as a time average. So this is time. Again, if it is a periodic signal, if xt is periodic with time period t naught, then I don't need to evaluate it for infinite time, but I can only work from one time period. वन टाइम पीरियड में जितना AC पावर आएगा वो पूरे टाइम पीरियड के लिए पावर हो जाएगा. So this will be xt minus xt square dt. This is called AC power. So again, I will have the same condition. Total power should be equal to DC power plus AC power. Total power is nothing but x square t. DC power is nothing but DC square, and AC power is nothing but xt minus DC, इसका एवरेज, सॉरी इसका स्क्वायर का एवरेज. दिस विल गिव यू AC पावर. एनी डाउट इन दिस रिलेशनशिप? नोटेशन जस्ट चेंज किया है
No,
मैंने.
sir.
Everything remains same, but now if you see, this is called time averages, because you are finding what? You are finding the average over the time. So you are asking the question on an time average, on an average, किसी भी टाइम पे अगर मैं पूछूं कितना पावर होगा, so that will किसी भी टाइम पूछूं कितना एवरेज होगा, that question is given by this what? This time average quantity. So the notation is just different, otherwise same thing is happening over here. We just check this. This is capital xt, and think like this is just a random variable. It's a random variable because you have fixed the time t, then only it will be random variable. So you are fixing the time. I hope this is clear. So this is a random variable. This random variable can contain DC as well as AC. When you square it and find the average, you will get total power. And when you subtract the mean, the DC, when you subtract the DC value from this total random variable, you get only AC part of that random variable. And when you square it, you will get the total power of that AC component. Yes or no? Yes or no?
Yes,
Yes.
sir.
यहाँ पे भी वही काम किया है भाई, मैंने कुछ अलग काम नहीं किया है. इधर भी वही है, उधर भी वही चल रहा है. AC पावर निकालना है तो आपको पहले DC सब्ट्रैक्ट करना है, फिर उसको स्क्वायर करके उसका एवरेज निकालना है.
Square.
सेम यहाँ पे किया हमने. एवरीथिंग इज, वी आर डूइंग सेम थिंग हियर आल्सो. How I can define autocorrelation now? So this is about what? Okay. Can you tell me what is the average of this? Can you tell me average of, suppose, any function of xt? क्या होगा ये? लिमिट क्या होगा? लिमिट t टेंड्स टू infinity
Infinity 1/t
minus t half to plus t half,
plus
and
t.
this will be
G of x. G of x. अच्छा,
of
yes.
जी ऑफ एक्स टी, सही है, सही बोल रहे हो, जी ऑफ एक्स टी डी टी. इज दिस क्लियर?
Yes.
दिस इज कॉल्ड फर्स्ट ऑर्डर टाइम एवरेजेस. फर्स्ट ऑर्डर क्यों बोल रहा हूँ? क्योंकि एक ही फंक्शन इन्वॉल्व किया है आपने. एम आई करेक्ट? सो ये फॉर्मूला सबसे इंपॉर्टेंट फॉर्मूला है. तो आप कोई भी फंक्शन ऑफ एक्स टी लीजिए, उसका एवरेज वैल्यू ऐसे निकालते हैं. अभी जी एक्स टी आप बोलेंगे कि ये एक्स टी है, देन आई विल हैव this xt and this is called time dc value in time. If you say g of xt, g of x of t is x square t, I will say this is average of x square t, and this is called mean square value, or you can call it total power, whatever you want to call it, total power. And if you take gxt but remove your DC component, so you'll get only AC component, and to find the power you need to square it, and then finding the
Average.
average, you are going to call it DC power, sorry, AC power. This is called AC power. And since we are studying only what this three only we are going to deal with, other function you can create by yourself. You can take sine of xt, why not? You can take x cube t, why not? But check the point here, I have written a small x, I have not written capital X, because we are talking about one sample function. So this is the one function, or it's just a one sample function, or you can say just what, only xt. What is the autocorrelation? Let's find out time autocorrelation. Let me take new page. ये भी पढ़ा है आपने जब आपने क्या पढ़ा था, सिग्नल सिस्टम. लेट्स चेक दिस वन. अभी मैंने बोला है कोरिलेशन मतलब क्या होता है, दो रैंडम वेरिएबल का मल्टीप्लिकेशन होता है, जब हमने पहले बात किया था. नाउ यू आर इन्वॉल्विंग टू थिंग्स. लेट्स से टू थिंग्स इज व्हाट, एक्स टी, और दूसरा क्या बोल रहे हैं अपन, इसको अपन टाइम में शिफ्ट कर देंगे, टी प्लस टाउ. और यू कैन से दिस इज एक्स टी एंड दिस इज एक्स टी प्लस टाउ. like let me write that again here so that we will understand. Statistical autocorrelation was what? There we take one at one time xt, and the second time is xt plus tau. You can write t1 and t2. So this is t plus tau is t2, and t is t1, but I have defined just xt and xt plus tau two times, correct? Now see this question, see this point now, and when you multiply them, you get expectation of this thing. So same thing, when you multiply them and when you find the time average, you get this thing. Yes or no? Yes or no?
Yes, sir.
So let's write the formula. Let's write the formula. How you write it? Minus infinity to infinity, and you write whatever goes inside this triangle, it goes here. And this is dt. Am I correct? Oh, sorry. It's not. It is again limit, right? Can you tell me the definition?
1 by
So limit
limit t tends to infinity. 1 by t.
minus t half to t half. This will be xt plus tau dt. So definitely it's going to be function of only what, tau. Yep. Yes or no? It is going to be function of only tau. Tau is called time shifting or time difference, or you can say time shifting. We take the xt, this one, we take this xt, we take this xt, shift it by tau, and multiply them, and then find the area under the product, divide by capital time t, capital T. Is this point clear? So इसका जो notation है, again अभी लोग बोलेंगे कि इसका नोटेशन क्या यूज करना चाहिए, यहाँ पे RX यूज करूँ तो फिर से अपने को प्रॉब्लम होने वाला है. So it is in general as a function of tau, but when I say this one, I have to write something there, right? Otherwise it will create confusion. So it's better that we will not use this one. We will use always this notation. Sometimes people denote it by, I don't remember that, wavy bar, or they denote it by only horizontal line. You just check this one, what is that? But this is only going to be function of tau. Here there is no point of WSS and all those things. It may be, it may be not. It has to be always function of time tau, right? This is called time autocorrelation. ये फॉर्मूला पहले भी देखा है आपने. If again, if xt is periodic, this time period t naught, then you can find for one time period, and this will be minus t naught half to t naught half, and this will be xt plus tau d tau. Again, when I say t plus tau, I can write minus also, I can write minus also. It will not change the problem. It will not create the problem because it has to be function of, it should be even function of tau. अभी आप इस वेव फॉर्म के लिए इस तरफ शिफ्ट करिए, इस तरफ शिफ्ट करिए, it does not matter, right? So it can be plus minus, it can be plus minus. So generally we choose plus. So these are what, when we have real valued function. When you have complex valued function, you choose one as conjugate, right? So here we are assuming that all the functions are what, real valued. There is no imaginary and complex. We don't have to complex conjugate this one. So this is called time autocorrelation. What is time autocovariance? Yes, क्या होगा? I will choose xt again, and next will be xt plus tau or minus tau, whatever it is, xt plus tau, let's say. And what you do, you first take xt and subtract the mean of this xt from it, and then you take xt plus tau, subtract the mean of, and what you find here, this autocovariance, time autocovariance, xt नो चाहे शिफ्ट कर दो, डीसी वैल्यू चेंज होगा क्या इसका? Will the DC value will change? If you have sine wave here, if you shift this sine wave somewhere here, will the DC value change?
No, sir.
No, right? So it does not matter there. I will not write this one now, but this is what the, you can define n numbers of this based on this xt, right? So how many function I can define based on this xt and xt plus tau? I can define any number of function. Again, same thing, right? Infinite number of things. So let me write that. So you can have in general as a function of xt and xt plus tau. You can write as a t1 and t2, no problem. I have written xt and t plus tau. You can write t1 and t2. Let me write t1 and t2 here. I can write t1 and t2, no issue. So this is what it will give you. It will be limit t tends to infinity 1 over t minus t half to plus t half, and this will be g xt1 comma xt2 and then dt. This is what, how many function I can define? I can define infinite number of time averages according to this formula. So this formula is very important for two function. Means only two function. I have taken two function only, right? Now let's come to point to the ergodic process. What ergodic process says? When statistical average are equal to the time averages. How many statistical averages I have? How many I can take the statistical averages? Then the process is called ergodic process. How many statistical averages I can have? Yes. कुछ देर पहले यही बात कर रहे थे अपन. How many statistical averages I can define? I have defined only 5, but how many I can define? Yes. बोलो. कितने फंक्शन बना सकते हो आप? ये क्वेश्चन पूछ रहे हो ना, कितने फंक्शन बना सकते हो? दो फंक्शन को लेके या 3 फंक्शन को लेके, बताइए. यस. बोलो. How many function I can define? How many statistical averages I can have and time averages I have? Say something. What is that?
Infinite.
इतना देर क्यों लगता है? क्लास में भी 10 बार कम से कम पूछ चुका हूँ मैं, आपको याद होगा करके. Infinite. So to prove that, to prove or to check for a process, for a random process to be ergodic, how many condition I need to check? Yes. How many condition I need to check? वैसे नहीं चलेगा ना अभी. To check for infinite, right? So I need to check infinite conditions. Nobody can check that one. Nobody. Right? Let me write some statistical averages. See this point. Suppose I want to check with DC value, right? Suppose check the DC value. Let's check for DC value. Let's check for DC value. DC value, statistical average, how I write? Expectation of xt. This should be equal to minus infinity to plus infinity x fx xt dx, and this should be equal to this time average. Yes or no? Yes or no? This is what we are saying, no?
So
Statistical average. This is statistical average. So statistical DC value should be equal to time average. Means what? Let me write the formula for that. Limit t tends to infinity 1 over t minus t half to t half xt dt. I need to prove it. Okay, okay, this is one of the conditions. This is time average. This is time. In time, how to find DC value in time is this one. How to find DC value in statistical sense, this is this one, right? What about you can find total power, AC power and all those things, but in general, if you have suppose any function of xt, let's say for g of xt, right? So this will be what? Expectation of g of xt. It should be minus infinity to plus infinity g of small x fx x t dx. This is a statistical average of this gxt, and this should be equal to, see this, I've written small x. See this, I've written capital X, because we are talking about random variable here, we are talking about sample function over here, and that should be given by limit t tends to infinity 1 over t minus t half to t half g of x of t dt. How many function you can define? You can define infinite number of function on this. This should be equal to this. Oh, you are asking me something this. Now let's go to this is the first order, right? We go to second order. Then I can have simply suppose autocorrelation, right? So let's find for autocorrelation. So how autocorrelation is written in statistical sense? This is defined by Rx T1, or let me write T and T plus tau, or let me write T1 and you can write T1 plus tau, whatever it is. We can define anything. So this average should be equal to the time autocorrelation function as well. I hope this is clear, right? So you write it by yourself. I am not writing it because I think I don't know how many times I've written it. You write it. So अपन बोल रहे हैं कि ऐसे कितने प्रॉपर्टीज हो सकते हैं फंक्शन ऑफ xt and xt1 and xt2. There are infinite possible random means what infinite possible averages in statistical as well as time, and the corresponding averages must be equal to each other. So that in that case we are going to call that process as a ergodic process. Ergodic process is more restricted condition than what strict and stationarity process, right? Now see this time. In general, we have in general in the question what we get. They say something what find whether the given process is ergodic in mean. They may ask the question like find whether the given process is ergodic in autocorrelation. When they say this one, they are asking you to just find DC value in time and autocorrelation in time. So they are asking you to find time autocorrelation and time mean, and check whether this time mean and time autocorrelation, they are equal to I should say statistical DC value and statistical autocorrelation value. This is what they ask, right? I hope this is clear. So they ask ergodicity in mean. So this term is important. They are asking only, is it ergodic only in mean? Is it ergodic only in autocorrelation? They are asking like this question, right? So I hope this is clear. I will not go into detail now. You can just check this, what is ergodic process is, but this is how the ergodic process is defined. You just solve this problem and you will be done. So let me write this question number 6 because 5 question I have already solved. So just watch the part 2 video. Last numerical was part of 6. So let me write a different question. Let's say question number 1. Let's say. So let's define one random process xt equal to a cos 2 pi fct plus capital theta, where theta is uniform random variable over minus pi to pi, and a is just a constant. A is constant. There is nothing there in a is constant, but I've written capital letter, right? So it's amplitude, so I've written capital letters. So I've written this is, I'm just saying that when this is constant, it has to be, it is constant. So the first question is what is xt WSS process? This is the first question. Second part is xt is ergodic in mean and autocorrelation. So these two questions can be answered if you know WSS process. For WSS process, which condition I need to satisfy, and for ergodic in mean autocorrelation, which function I need to satisfy. So the solution, a process, a random process, is said to be a WSS if and only if the expectation of xt, which is mu xt, should be constant. So this should be constant. I've talked it in the lecture only, this one. And autocorrelation, which is defined by xt, or like xt1 and xt2, whatever you want to write. Some people call it expectation of xt and xt plus tau. So they write t1 as t and t2 as t plus tau, and they write this as a t and t plus tau, and they ask whether this is only function of time difference or not. So here you ask whether it is constant. I've written mu x only, not function of time. So you check whether this is true or not. If this is true, then only you say the process is random, WSS process. So this two-part calculation, we have already done it, right? So have done already in numerical 5 in part 2 video. So I can write this expectation of xt, there I got was 0, and autocorrelation function, that is t1 or t2, whatever you to write, or you can write rx t and t plus tau, that was a square by 2 cos 2 pi fc tau. So we saw there, this was the part A there, and part B there it was in that numerical. So this you can see, this is a constant, and you can see this is only function of time difference, function of time difference. Hence I can say the given process is in fact WSS process, because these two conditions are satisfied. Now to solve part B, I need to find, I have already find statistical mean and statistical autocorrelation. Corresponding time mean and time autocorrelation I need to find in part B. So let's go with the part B. So part B, a process is said to be ergodic in mean if and only if expectation of xt is same as, so you check this condition, same as this xt or not. Let's check this first, or let's write the second thing also. A process, a process is set to ergodic in autocorrelation if and only if expectation of xt plus tau is same as time autocorrelation or not. So if this is true, I will say this process is ergodic in mean. If this is true, I will say this process is ergodic in autocorrelation as well. So let's check the first condition. So this is condition 1, condition for ergodic in mean, and the second condition is for ergodicity in autocorrelation. So let's check first condition 1. So condition 1 says you need to find xt. So this xt is nothing but a cos 2 pi fct plus, I can write now is a small theta. I don't require capital theta, and this theta can be any value between minus pi to pi. So this theta can be any value between minus pi to pi. It is uniformly distributed, but it does not matter now. All the time whenever you differentiate, integrate, you just need to consider this as a constant. So I will treat now this as a constant, and only t is varying. So only this t is variable. This is just opposite case. Only time is variable. Theta is now, I will take this as a just constant because now everything is with respect to t. So this will be limit t tends to infinity 1 over t minus t half to t half, and this will be xt dt. But the point is, since let me write xt is periodic, so I can write xt, you can see this is periodic in time. Xt is periodic in time with time period t naught equal to 2 pi by omega c. You can see this is 2 pi fc, so this is just 1 upon fc. So I can write this as a 1 upon t naught minus t naught half to t naught half, and this will be simply a cos 2 pi fct plus small theta. Now this is dt, it's not d theta. So when you integrate it, what do you get? So you should understand how I got from this to this, otherwise you have to solve this one. This, I'm not saying this you cannot solve it. Whatever you solve it here, there also you can find it same. But once we know that this is periodic, I can use the simpler notation because t naught is known and we don't have to worry about this limiting definition. So 1 upon t, and when you integrate it, what do you get? This will be simply a cos का integration क्या होता है? Sin 2 pi fct plus theta, and you need to differentiate this 2 pi fct and divide it in the result. So this will be integration of 2 pi fct with respect to t will be 2 pi fc. I don't have to worry about theta now. Those who have watched theta, you have to worry about only theta there. Now in time average, you don't have to worry about theta, you have to worry about only time. It is just opposite. You can think, you can see this. The lower limit is t minus t naught half to plus t naught half, minus t naught half to plus t naught half, and this will be simply 1 over t naught. This is constant, so I can take a is also there, so this will be a upon 2 pi fc, and rest thing is what? Sine 2 pi fct plus theta. So this will be sine 2 pi fc into t, upper limit it will be t naught by 2 plus theta, and the lower limit will be minus sine 2 pi fc, and in this case it will be minus t naught half plus theta, and the bracket is. When you do this, we know that since t naught is a time period and fc is the frequency, so this will be t naught is 1 upon fc, so t naught time fc will be 1. So wherever you get t naught and into fc, you replace it with 1. So this will be a by 2 pi, and t naught into fc will be 1, so this will be 1. And here also I get sine 2 pi, and here I get fc into t naught, so this will be 1, that will be 1 by 2 plus theta, and this will be sine fc into t naught with minus sign, so it will be minus 1, so this will be minus 2 pi into t naught by 2 plus theta, and this is done. Okay, it's not t naught, it's a 1. So this is 1, right? 2 and 2 got cancelled. This is the different color. So this 2 and 2 got cancelled. Here 2 and 2 got cancelled. You get finally as a upon 2 pi. Why I'm doing this? I should get 0. There is no way that sine for one cycle the DC value has to be 0, right? It has to be. Why I'm doing this? Okay, but let's do, because the range is 2 pi, right? This t naught is from minus t naught half to plus one cycle is again going to be, it has to be 0. So this will be sine pi plus theta, and this is minus pi plus theta, so this will be sine. Whenever you go with this sign, no, go very slowly, otherwise you will make mistake. So this will be a by 2 pi, you can sine pi plus theta, and now minus pi plus theta है, theta minus pi लिखा हुआ है, so I can change this one, so I can write sine of minus pi minus theta, and then I can apply sine of minus theta is minus sine theta, so this will be sine of pi plus theta minus sine of minus theta is minus, so minus minus plus, and this will be sine of pi minus theta. Sine of pi plus theta is minus sine theta, so this will be minus sine theta, and sine of pi minus theta will be plus sine theta, and you get this, and finally you will get 0, big 0. This is equal to expectation of xt from equation 1. What is equation 1? There we this derivation you can see in the numerical 5 in the part 2 video, that is 1 which is 0, so here it is also 0. So I say hence, since xt time mean is same as statistical mean, hence the process is ergodic in mean. Next is what? Second one is what? Condition 2, which is checking of what? Ergodic in autocorrelation. Fairly simple. Again the same thing. So this will be xt, and this will be xt plus tau. The formula will be limit t tends to infinity 1 over t minus t half to plus t half xt plus tau dt. Since xt is periodic with t naught, hence the formula becomes 1 over t naught minus t naught by 2 to t naught by 2 with time period t naught, that is equal to 1 upon fc. So xt is what? A cos 2 pi fc t plus theta. So this is my xt. What is xt plus tau? So you need to replace t with t plus tau. So this becomes a cos 2 pi fc t plus tau plus theta dt. Why we are doing this thing? I should not do this. Don't open the integration till you go in the bracket form. So I can write a, or you can do this. If you want to do it, you can do it. Otherwise, it's don't open it. Never open it. Otherwise, you get complicated expressions. But let's we कर दिया हमने, कर देते हैं यहाँ पे. So this will be a square. There is a. There is a. This is my xt plus tau. A square. This will be t naught. This is minus t naught half to t naught half. This will be cos a cos b. So this will be cos 2 pi fc t plus theta and cos 2 pi fc t plus tau plus theta dt. You can write this as a cos c, and you can write this as a cos d, and you can apply cos c into cos d formula. So the cos c into cos d is nothing but cos c plus d plus cos d minus c or c minus d, whatever you want to write, you can write it. I will write d minus c. You can write c minus d because cos of minus theta is cos theta. It does not matter. So cos c plus cos c into cos d will be replaced by this one. So you get a square by t naught. This will be minus t naught half to t naught half. What is cos c? So let's write cos c plus cos d. So this will be 2 pi fc. This will be 2t plus tau plus theta. This is one term. Second term is simply plus a square by t naught, and I need to divide by 2 because 2 is there. So this will be 2 t naught. This will be minus t naught half to t naught half. This will be cos. Now the difference is difference. Okay, this is 2 theta. I forgot it. This will be 2 theta. When you add them, cos 2 pi fct. Here it is cos 2 pi fct. So this will be 2t, and tau is only here only, so it will be only tau. So cos 2 pi fc 2t plus tau. Theta is there, so it will be 2 theta. When you subtract t plus tau minus t will be only tau, and theta minus theta will be 0. So no theta here. So this will be cos 2 pi fc tau, and theta is 0. So this will be dt. Right. Now you can understand this one, the first one. The first I should say this one. Let me take it here, somewhere here. Let's say here. This is t naught. Okay. This is t naught. What do you find? You can just assume this is part 1. You can solve it separately, and this is part 2, which you can solve separately. इसके बाद मैं नहीं बता सकता, इसको आप खुद से करिए. Part 1 will give you 0. Part 2 will give you what? Part 2. Let's derive it. Part 1. What is part 1? Is a square by 2 t naught minus t naught half to t naught half. This will be cos 2 pi fc 2t 2t plus tau plus theta dt. You can differentiate it and you can give it to 0. I'm not doing it. Do it by yourself. Do it by yourself. And part 2 is, I will do part 2. What is part 2? Part 2 is a square by 2t naught. It is minus t naught half to t naught half. This is cos 2 pi fc tau dt. And you can see this one. This is just a function of tau. It is independent of time t, so it can be treated as a constant independent of t, hence constant. So this will be a square by 2t naught. It's a constant, so I will take it outside. So this will be cos 2 pi fc tau, and you have just minus t naught half to t naught half, t naught half to t naught half. This will be dt. So you can assume this is 1 dt. What is the, this is a square by 2. Let me write cos 2 pi fct, and t naught I have just left over here, so I will write here because it makes sense. It will, integration of 1 will be simply t, and this is from minus 2 to t naught by 2 to t naught by 2. Oh, why I am writing so many steps? You go very slow, but you take time. It is a problem. T naught by 2 minus of minus t naught by 2. I am just showing that one, why this is so crazy, you know. I just fed up now doing this again and again. So this is 1 upon t naught. So t naught minus of minus will be t naught. This and this got cancelled. You get a square by 2 cos 2 pi fct, and it is exactly same as rx tau. So we said that when xt and xt plus tau, the multiplication of this two, when you take time average, this is in fact equal to what? Expectation of xt times expectation of xt plus tau. Hence, the given random process is also ergodic in autocorrelation. So this numerical comes for 10 marks if it is going to come, but unnecessarily if you follow the steps, you will be in trouble. I will, anybody is having any doubt? किसी को डाउट है इस पे? हाँ बोलो आकांक्षा, इसी का नाम याद हुआ है मेरे को अभी तक, सिद्धांत. यस
No, sir.
ठीक है. सो अननेसेसरली अपन बढ़ाएंगे नहीं स्टेप्स को. क्या करना है मैं आपको बताता हूँ. हमारा यही सॉल्व करना था. कैसे सॉल्व करेंगे इसको? Don't open the integration till you don't require. You just go in this way only. A cos 2 pi fct plus theta multiply with a cos 2 pi fct plus tau plus theta, like this. I have not opened the integration. I will not write it till I don't get something. A square, this will be cos 2 pi fct plus theta cos. Please go and check the trigonometric identities, otherwise आपको फॉर्मूला आएगा, आपको सब कुछ आएगा, बट आपको आइडेंटिटी नहीं पता है, तो उसकी वजह से आपको प्रॉब्लम आ सकता है. नाउ लेट्स अप्लाई द cos c cos d formula. Here I will apply cos c cos d. So you can see this is a c, you can take this as a d, and cos c cos d you can apply. I will apply it. So I will get I square by 2 cos 2 pi fc. One is the term which is addition. So addition will be, here t is there, here t is there, so this will be 2t. Here tau is not there, it is only tau is there, so it will be plus tau. Theta is there, theta is there, so this will be 2 theta, and plus a square by 2. Next component will be difference, so this will be cos 2 pi fc. I will subtract this, I will subtract this from this, d from c from d, because cos minus theta is cos theta. So whether you write cos c minus d or you write cos d minus c, it does not matter. So I will take this, because unless unnecessarily I will get minus sign otherwise. फिर से मैं इसको plus करूँगा, कोई मतलब नहीं है. So cos 2 pi fc, t is there, so they will cancel. Only tau will remain. So this will be cos 2 pi fc tau. I hope this is clear. Theta is there, subtracting theta from theta will be 0. So this will be 0. No issue. I will write this. इंटीग्रेशन नहीं लिखेंगे तो अपने को इजी जाता है. So this will be two terms. So this will be cos 2 pi fc 2t. Let's write this as a 2t here, plus let us write this cos 2 pi fc tau here, 2 pi fc tau plus 2 theta. I have just opened this this bracket. So this is t, and these are just constant because they are independent of time. They are independent of time, so they are constant. This is only there which is time dependent. This will be now expectation of sum is nothing but sum of expectation. That's true. So I will take this outside. So what I said, expectation of, if you take x plus y, so this will be x plus y. I've just written this xy, but otherwise it will be some different thing, function, no? So this will be xt plus suppose yt, and you have to find. So this will be xt plus yt. But don't make mistake when you write xt into yt. It does not this one. Expectation is a linear operator and plus is a linear operator. So expectation of addition is the addition of expectation. So addition of expectation. But expectation, this multiplication is a non-linear operation. So you cannot write expectation of multiplication as multiplication of expectation, right? If they are independent, then only you can write. If they are independent, if they are orthogonal, DSP में पढ़ रहे होगे आप, orthogonal क्या होते हैं? When the inner product is 0, orthogonal बोलते हैं उसको. Okay, we will not go into that. Okay, so you cannot write it in time. In statistical sense also you cannot write. So if I have, let me write that, x plus y, you can write it, expectation of x plus expectation of y. This is true, this is not true. If you write expectation of x into y, and if you write, you cannot write, so this is not true, that expectation of multiplication is not multiplication of expectation. This is true only if x and y are independent. Then only you can write this is expectation of x into expectation of y. Otherwise not. So don't make mistake. But whenever you have addition term, you can always take the expectation of addition to be the addition of expectation. So this will be a square by 2 and then cos 2 pi fc tau. Okay. Sorry. Now see this point here. Cos 2 pi fct. So this will be simply, what should I say? This is simply 2 into 2, that will be 4. So I will write, let me take a square by 2 here, and okay, do this one, cos 4 pi fct plus constant. Let me write this as a constant. Why I'm taking this again and again? Whenever I need to replace constant, I will replace with constant. Let me write constant 1. So let me write constant 1. This is there, okay, no problem. Now this is plus a square by 2. What is this? It is independent of time. This is constant. अगर किसी भी कांस्टेंट का डीसी वैल्यू निकालोगे तो वो खुद कांस्टेंट होगा. यस और नो? यस और नो? यस और नो? अगर कोई कांस्टेंट है आपका ऐसा, ये इसी को बोलते हैं ना कांस्टेंट. यस और नो? यस और नो?
यस.
सो इसका अगर एवरेज वैल्यू निकालोगे तो क्या मिलेगा आपको? ये खुद ही मिलेगा ना, इसलिए तो बोलते हैं इसको डीसी सिग्नल अपन. Yes or no? Say yes or no.
Yes, sir.
What's the DC value of this signal? It's a 3 only, because it's a constant throughout. So similarly, cos 2 pi fc tau, it is independent of time. So you can assume this is not 3. It's a cos 2 pi fc tau. Why I am opening that integration and doing all those things, right? So this will be, expectation of any constant is constant. It is also true for random variable. So this will be the constant itself. So cos 2 pi fc t, and check this. This is what cos signal. You can assume this constant 1 as 0 because this is constant. Let's say this is 0 for the time being. What do you see? Cos 4 pi fct. Cos 4 pi fct. It's a periodic signal. If it is a periodic signal, its average value has to be 0 because this is cos signal. Cos is periodic. Cos is periodic with average value 0. You can check this. See, cos is something constant is there, so it will be some shifted version of cos. This is cos, this is cos, this is cos, whatever it is. But when you find for one time period, what do you get? Plus area minus area, total area is 0. And when you divide by T naught, so total area is 0 and divided by T naught will give you 0. So this term is 0. By writing that in terms of sentence also, I can simply say it's a 0. I don't have to evaluate it. It's for cos 2 pi fct, but it can be for cos 4 pi fct. It will be twice oscillating than this one. So if you have multiple of 2 pi, this thing, this thing, if it is multiple of 2 pi and you are integrating over one cycle, then it has to be always zero, always zero, always zero, because integer of 2 pi means you are taking the integer number of cycles, so you will get positive area same as the negative area, so the total area has to be 0, and when you average it, that is over t naught, you will get 0. I hope this makes sense. Anybody is having any problem in this? Yes, समझ में आया क्या? Say yes or no. बोलो. No or yes? Yes or no? Don't know. Is it clear now why it is 0? बोलो कुछ.
Yes, sir.
So this will be 0 and this will be a square by 2 cos 2 pi fct. Check this out where I have written integration. I have not written integration anywhere, but I still able to solve this if you know the physical meaning, physical significance. If you don't know the physical significance, then you have to do complicated mathematics, or it may be simple mathematics, but the lengthy proof. So if you want to skip lengthy proof, you have to understand the physical meaning. What is the expectation of any constant? What is the expectation of a cos over a complete cycle? You need to understand that. You want to do it, you can do it in the exam. For this, after this you can open. After this, if you want to open the integration, you open this. But you know the formula. Whenever you have triangle, you know the formula now. Whatever inside there, it will go inside the integrator. And if it is periodic, then it has to be for one cycle. After this, if you want to open, you can open it. But my suggestion is what? Till the point you can go inside this triangle, go there. And when you cannot move further, then open the integration. Avoid directly writing integration. If you from the first line itself, if you start writing the integration, you may be in this situation. Where is that? Sometimes I proved it. No, where is that? It's not there. It's here. Okay, so I interchange this this slides. Okay, see this, how much line I have written. Let's see this. This, go on. Now this. But I told you to do it by yourself. See here. Where is that? This one. Right? I wish from the starting only I have written this integration. I have opened the integration. Why? I should not do that. Right? And in this also, I have not proved this one as 0. You have to prove it 0 from your side. I said it like this. Prove it by yourself. Do it by yourself. So it requires more than these lines. And check this one. Done. So this is what done from my side. And I just interchange this one. So I will, can I keep it there? Yes, I can keep it there. This is the end of at least for unit test. From up you go to home and you are in home only. Read it by yourself. Properties. I told it in the class also. Properties of autocorrelation function. Of a WSS process. There are 4 to 5 properties. You read them. Try to understand those properties meaning and the properties of power spectral density of a W process. They came for 5 to 6 marks without proof. If you just write those properties. But sometimes they come for 8 marks. In that case, they ask proof each and every properties. So the proof you have to understand. These 2 things you just do it by yourself. and only 2 topics will remain, which we will cover after unit test. But this is done from my side. I will upload this video and the lecture video which we have conducted in morning on the drive. So there are 4 videos I have already uploaded, 5th and 6th. So this will be 6th video. 5th video is the class video. So those 2 video I will upload on Google Drive today, right? So maybe it till 9 o'clock I will upload it. Any doubt in this, or anything that you want to say for this unit number 3? It may be boring, it may be something you may feel bored, but once you understand the idea